Hello and welcome to this Blender tutorial. My name is Chris and I'm going to, and this is a tutorial that I'm just going to cover in a series. It's regarding the design of a more scale specific or accurate scale designing in Blender for computer aided design type work. The equivalent of it in Blender, how you go about doing that. I do highly recommend that with this tutorial, you've watched my previous tutorial and kind of getting things set up. Kind of covers general design, kind of general design layout principles and getting your model design set up. This will cover a little more extensive details, such as incorporating blueprint or incorporating like the media such as plywood in the design work, that is in terms of your mesh construction. So what I was going to focus on is not necessarily the things that were covered in the previous tutorial. I'll actually just cover some of the basics of incorporating, like if you were wanting to include the thickness of the walls of your your design layout wall thickness. I'll get into covering that, and then an extrusion, a step extrusion, a Z-level step extrusion that covers setting up the wall thickness when you're doing that work. And then I'll go to a completed kind of single unit object model. We'll go to that design and then show how to break that design down into component parts that can be used again, and that's in sequence to this kind of whole tutorial series on that culminates in for instance, getting the blueprint designs or to-scale spec design work that kind of culminates to that. So this kind of covers the work of doing more in-depth work that leads to kind of like a completed prototype. This doesn't necessarily complete all the steps, that would get your mesh geometry set up for 3D printing, although this is a very, very and extremely good start in getting to that work. For like 3D printing, I highly recommend reading like guides on the type of the necessary ingredients or requirements for mesh design work. And part of that includes that your geometry is supposed to be manifold versus non-manifold. And what that means is that that you don't have any non-enclosed, I believe it's non-enclosed geometry. In other words, you have to have a wall thickness included with it, and that there is like a closed loop geometry with it. So there's actually I believe a Blender add-on that allows, if you type in like under File and then User Preferences, you can type in 3D printing, and I believe it'll pull up well, let me go to all here in the categories, but 3D print, well, it's not showing there, but I'm pretty sure there is, Mesh 3D Print Toolbox. That's an excellent tool that will allow you, especially if you're using it in edit mode, it'll analyze your mesh and tell you what's wrong with it, like in terms of the things that you need to resolve when doing a 3D export from Blender or getting it all prepared for an STL export. So I do highly recommend, though, doing any sort of read up and setting up for 3D print. I'm not going to cover that in this tutorial, but instead I'll give you kind of some more nitty-gritty hands-on working knowledge in setting up your mesh for more detailed print prototype specking here. So the first thing is that, and I've indicated on my blog website, like at the outset, some prerequisite data for the design. I covered it in the first tutorial. I'm not going to show the setup of how I got to this 31.75 centimeters by 12.7 centimeter layout. But I will state that the first tutorial kind of covers getting, you know, your plane set up, how to do that specifically, and the techniques for doing that with your numeric pad when you're rescaling like the plane. So we do have it those set up, and I've, by the way, translated from inches in this case from inches to the metric system, and I've just used conveniently, it's a Google centimeters or metric to imperial conversion, and vice versa when translating this data. The prerequisite data also includes the switch holes were like 9.75 millimeters in diameter, and then I have LED holes at 3 millimeters diameter, and then plywood thickness. That's something new added with this tutorial, a plywood thickness, wall thickness of 5.088 millimeters. So that's what we're going to do, is kind of do like the basic layout of the walls in this given spatial area. So in order to do this, I'll just go ahead and get started here. I would comment that it also helps when you're doing like something that's kind of repetitive. Just remember or write down like the numbers that you typed in that you know, correspond with what you're doing, that repeats the same procedure. That'll save you work wherever you need to kind of repeat what you're doing, but you can't do it, you know, for like, you can't do it all in one. So in building the wall thickness, there's kind of two ways of doing this. We could do a loop cut and slide to where we have like another the vertical line that is approximately 5.08 millimeters relative to this line that I'm showing here that's up and down vertical, that we want to put in a wall representing that edge or that plywood thickness. The other way that I wanted to show that avoids the loop cut and slide but gets into more like technical work with the mesh, actually deals with extrusion. So we can kill two birds with one stone by selecting two vertices and then extruding these vertices on a X restricted axis basis. So to do that, we've just hit EX, and then I have the numbers kind of memorized and extruding it to the approximate appropriate thickness for the desired wall, which is 5.08. So it's like 0.033, and then 8.666. So something like that, 0.0338666. So that gives us exactly for the wall thickness, when I went and measured directly the media that I had, that gives us exactly the desired wall thickness. We can verify that just by selecting these two vertices, and we come up with down here 5.08 millimeters for the thickness, the given thickness that's shown. So we'll select these two vertices here, and I'll extrude again, y-axis, similar deal, 0.03388 or 666, and we need to go, I believe, in the opposite direction here. So we'll change the sign of this. Just hit the negative button or the minus subtraction key on your numpad, and so that puts a wall exactly where we need it. we can, so that represents another plywood wall thickness. And then we select these two vertices, do the same thing, EX 0.03. Whoops, I accidentally made a mistake on my extrusion, so we'll hit Control Z to back it out. Hit that again, EX and 0.038666. Hit the negative sign because we have to extrude it opposite direction, inward. You can kind of visually see that. And then we'll select two more vertices, and that'll complete the extrusions that we need for the plywood wall thickness here, 0.038666. So we have now a completed extrusion for the walls. Now the problem that we also may have is that we actually want to be able to work with this in terms of like the vertices. So it may be wise where we have like where we can work with the like the intersection of two walls. So we probably may want to construct a vertex where it is we have this broken down into like a face here representing the intersection of two plywood walls, and then we have a face here representing this section, and then a face here, and so forth. So we'll actually rework this mesh before we actually get into further work of it. I'm actually gonna once we get through this, I'll just skip to the next step, cover the next topic that I wanted to cover in the tutorial. I'd leave it up to you to be able to use the principles that I've covered in both of these tutorials up to now, in getting to the kind of more completed scale mock-up that you're looking at before we actually do the next step in this tutorial, which is breaking this up into component parts. But in any event, with this, I wanted to go ahead and rework this mesh a little bit more in terms of the faces. So I'm going to go ahead and create for the intersection of the two walls another vertex, and I'll do something that's like EX extrude, but we don't have to type in the 0.038 all that business. Actually, I'm going to hit Control Z back out of that real quick. We can use the snap function down here that I'm showing, snap during transform, and we can snap to the closest vertex. And the nice thing is if you want to replicate like a measure, you can do so using existing vertices. So we know that for the X length, this vertex right up here matches the length of the intersection between the two plywood walls, or it would be the interior vertex representing the intersection of the two walls. So I'll go ahead and select this vertex here and we'll extrude it X on the X-axis, and then I'll just run my cursor, like literally run the mouse cursor up to the vertex, and lo and behold, it translates or extrudes on the X restricted axis to exactly that position. That's the snapping is an extremely handy tool because it'll save you a lot of like numpad work once you get your vertices set up on your mesh, so you don't have to remember like, okay, this is what I typed in, for an actual extrusion amount. So I'm going to go ahead and repeat the process of doing this, like EX again. Let's just select this other vertex down here, and we'll just do this for all four corners. So we'll have EX, and repeat that. And I'm changing the view, by the way, centering it by hitting the period key after I select a new vertex, and that allows us to conveniently roll the middle mouse button, middle mouse wheel, in and out to change the view where we can kind of clearly see what's going on. Not that it's necessary with that, but that's what I've done here. So we'll select all the vertices, go back into top-down view again. Now we want to actually rework the mesh, because if we look at the original mesh, we've just got a face covering the entire surface area, but we want to break this mesh down a little bit differently, where we actually have, in representing all of these vertices, faces, connected faces that are shown appropriately. So what I'm going to go ahead and do is delete just the face alone. Just hit the delete key and then select face, and that'll just delete the face. We'll need to delete these faces here as well. Now this won't, hopefully this shouldn't delete our vertices, so that we have the actual vertices as we need them. But we did run into a problem, which is that we ended up deleting our vertices. So I'm going to go ahead and undo what I just did, so that we don't run into problems and deleting again like that. So what we'll do is we'll select, like, this is kind of a little bit of tedious work sometimes in doing this, but sometimes it is necessary, as far as I know. There's no easy way of getting around it. So what we do is we go around selecting each of these groups of vertices, and you use the right mouse button and hold the shift key while you're selecting vertices, or you can alternately use the B or the C key, circle select, to select them. And you select the desired vertices, and then we'll fill it with the face. So we have to do that for each of these groups of vertices here. So I'm just using the shift and then right mouse button to connect these. So if you can't see it very well when you're selecting, you can always zoom in on what you've selected to see it more clearly. So I hit the period, roll the middle mouse button, zoom in, and we'll complete that. So hopefully everything, it looks like we've got what we need. We'll go back into, okay, so when we go back into, I went into down here, face select. I went from vertex to face select. If we toggle on, like, right mouse button click, you can, when you have overlapping faces for a given area, you can double toggle, or in some cases triple, depending on how many faces are kind of overlapped to a given region. So the new face that we constructed for this region, which is delineated by these 4 vertices that are shown, that is the new face. We don't want to delete that, so if we toggle, right mouse button, toggle it again, it'll select the old face that we do want to get rid of. So I'll go ahead and kind of commence through the process of, like, deleting these old faces so they don't get in our way. So we can also tell that the old face is overlapped with this slightly changed shading, viewport shading there, so it looks different. Kind of is a big clue that as to the differences there. So basically we have in terms of, like, the mesh that we want, we have everything kind of set up a little better in terms of, like, you know, that the faces, the structure of the faces, that So this is kind of like the basic layout. Like if you've got like the general, you know, you're working with the flat plane that would represent the bottom like of the pedal board. And before you do anything with the geometry, you'll probably want to go ahead and lay out the plywood thickness. It'll make it easier when you're doing the extrusions, not trying to work in that thickness later. So you've already kind of taken care of that. Now, if you were like in the case of loop cut sliding that I mentioned before, where we wanted to create two rows on the pedal board, you would need to account for the wall thickness, you know, on that new subdivision line. If, for instance, you've got a new set of plywood that's going in, so you'd actually want to divide, extrude on the new subdivision line, extrude on the y-axis, either above or below that division line, that subdivision line, so that its total length of either up or and below it represents 5.08 millimeters. I can actually kind of cover that, but I did want to cover when one other thing is when you're doing the extrusion. Let's see, I'll go ahead and extrude it up. Let's say we were extruding this by 1 centimeter for the step, representing the given first step, like of our pedal board. So I'll just go up and restrict it to the Z. I hit E and then Z. And let's see here. So I can't really see the dimension, but I'll just go ahead and move it as such to some kind of arbitrary figure. Okay, so we've extruded it up, and the problem that we're dealing with here is that we've extruded it up, but we don't have a representation, you know, of the wall thickness on the Z, either the Z. Actually, we've lost it, you know, entirely on the Z axis. In other words, we don't have the plywood thickness representing the floor of the object, or at the next step increment, you know, for the plywood wall thickness. So when you're doing like extrusions like of all of this stuff, you want to keep that in mind, incorporating the wall thickness. So I'm going to go ahead and back it out, the extrusion, and instead we'll just go ahead and extrude it like on the Z by 0.03, what is it, 3866. So we have already now the wall thickness of the sheet. This would represent like a plywood sheet, the thickness of the plywood sheet on the Z. And then we'll go up, you know, we would need to subtract out 5.08 5.08 millimeters from the next measure if you knew what your exact extrusion amount were. So in this case, I'm just going to kind of arbitrarily choose this and kind of go up a little bit for the first step. Now I haven't subtracted 5.08. So one possibility is that that I could actually do kind of a loop cut and slide. But it actually may be better just to go ahead when you're extruding like up, that you have incorporated like the 5.08 millimeters 2 times in reaching, you know, and extruding it upwards. So like if we had 1 centimeter, you would your first extrusion would be on the Z axis, it would be 1 centimeter minus 5.08 millimeters, or what is it? 1 minus 0.050, oops, 08. So so the first extrusion is just by 5.08 millimeters, but that leaves a difference of 0.9492 centimeters. Whoops, I think I got that math wrong there. So it was 1 centimeter minus 0.508, which is it actually leaves 0.492. Oops, I apologize. This has got to definitely be bigger than with 5.08 millimeters. This has to be bigger than a 1 centimeter extrusion, but let's say it's something like 3 centimeters. So we would subtract 0.508 centimeters, which would be 2.492 centimeters. But we would want to also subtract out 0.508 again, representing the next wall thickness. So that would leave us with 1.984, an extrusion of 1.984 centimeters going upwards. And then we would extrude it one more time by 0.508. So when you're kind of subdividing these extrusions, because you have to account for the wall thickness on the z-axis as you're extruding up, you want to take that into account as you're doing the extrusion work there. So that's something to keep in mind on that. And also, I'll go ahead and cover just kind of setting up the extrusion. I'm not going to go ahead and extrude this all the way up, but I'll cover like when you're adding a new loop cut, and representing this with a potentially new plywood cross surface. So in other words, if we have another plywood wall coming into play that is represented on this geometry, you'd want to go ahead and incorporate that into the design there. So for instance, what we would do to incorporate that is move this by on the y-axis. This isn't actually that complicated, but in a way it almost kind of does seem kind of complicated there. But let's see. Actually, I'm just going to go ahead and select these two sets of vertices, make sure that we've got it selected on the top. Oops, it looks like I selected the wrong one. So the easiest way sometimes to do this, oops, is to change the view, and then we'll go into box select with the B, and I just change the perspective view so that I have the ZY plane showing. So that selects the two sets. So we want to extrude that on the Y by approximately 5.08 millimeters divided by 2. So 5.08 divided by 2 would be 2.54 millimeter extrusion upward or on the Y constrained axis. So what did I say? 2.54. So that would lead us 2.54. Oh, we want that on the global Y, so 2.54. So we have 0.02. Oh, 1. 7, 6, 7, 8, 9, 9, oops, 8, nope, 7, 6, 2.54. So 0.016, 0.01696. I just have to remember that number. So repeat the process, selecting the same sets of vertices. So change to the go to box select, hitting the B, and I'm in wireframe mode, by the way, which is, you can toggle that by hitting the Z button. That makes it very convenient for selecting kind of in an X-ray manner right through the object, selecting vertices on a given like axis from a given view when you're doing like working with the circle select C or B, the B function. So we'll go ahead and extrude on the Y again, global Y, but we're going to go in the opposite direction. So I'm going to change the sign, 0.0166. What is it at? 9, 9, 9. Oop, I'm missing something. 7, 9, 9. Oops. 7, 6. There we go. So something like that. So what we should have for the length between these two, and I'll go ahead and draw this, but like if I were, and this may not actually apply, by the way, I'm just kind of demonstrating how you would, like if you're representing a new plywood wall, that maybe goes in the design, the model itself. Now, I don't think I actually incorporated anything like it, but anyways, this total length, if I take this vertex and hit F, the total length should be 5.08, and it looks like it is, so we're slightly off, 5.088 millimeters, which is actually 5.09 millimeters, so we're off just by 0.01 millimeters, which is a very, very small difference. So small that I probably will ignore it, even with the roundup consideration there. But yeah, we would go through the process of once you create the wall thickness there, you'll have to like extrude these vertices, these sets of vertices on either side of the line, the subdivision line, extrude it on a Z restricted basis, and I just selected them all, and then we already have the snap during transform set to vertex, so all I had to do was just on a Z constrained extrusion, select this vertex, and it automatically sends that group of vertex right down to the bottom there. And we'd repeat the procedure on the other side, and then we would connect all of these vertices, and rebuilding the faces, not only on this given new plywood wall that we've added, but we would need to rebuild the mesh in terms of all of the walls, existing walls. So it's something to keep in mind when you're working, and you're subdividing all the, keep in mind the necessary rework, when you're building these walls. In this case, we probably don't need to incorporate a second wall beyond, under the first step. It's only when we add the second step. So we don't have to worry about going down, extruding this down, since we're only worried about the second step, in building a new extrusion wall, plywood extrusion wall. So you can pretty much ignore having to put in you know, that going below it, you know, if it's not necessary, the new wall is only incorporated going up. In any event, that kind of covers what I wanted to cover for getting the design kind of like when you're doing more technical work with like these plywood walls. This is, again, a good basis to start with when you're doing it. So what I'll go ahead and do now, though, is skip ahead, and we're going to go ahead and toggle this out of view. And I'm going to pull up my completed design work that includes all of the walls that were done. So basically, when you've done all your work, your homework, and you got everything set up, you should have a model that looks something like this. I've included little LED holes, and then I've included like holes. These are actually to scale too big. This is these are 9.75 millimeter radius holes, which is way too big for like the switch that I had in mind, but I had to actually go and rework the mesh for each of these in order to appropriately get my switch design incorporated there. So, but in any event, the model's going to look something like this. Maybe if you have like a pedal board where you can see the plywood wall thickness that's shown here. One thing to keep in mind, well, I'll actually go ahead and cover it when we set up the components here. So once you have your model kind of set up the way that you like it, where you're representing like the plywood the wall thickness, we still have just one contiguous complete model surface. And we would actually like to break this down into component surfaces to make our work easier. So like with the component surfaces, we might want just part of the model, like I've just toggled from wireframe to solid mode here. We might want this area represented as one component for a given plate, you know, that we wanted to CNC mill or that we wanted to hand mill with the design spec blueprints. So then we'd have a top upper plate here shown that we would also maybe want to mill on our own. And then we have these side plates, like the side here, and then we've got this front plate, and then we got this plate here, and then we have this side plate here, and then we have this back plate. Of course, we have the bottom as well. So we would want to break these down into component parts. So I'm going to go ahead and toggle back into wireframe mode and go to edit mode. And in order to do that, we would want to separate the mesh and kind of work from there. And then additional design work, we might want to work, you know, if we had additional design work refinements, you know, maybe on just the component side end, as opposed to integrating it into the present mesh. Maybe we have some reason to do further refinement, but we want to do the refinements, you know, on a component restricted basis. But in any event, I want to go ahead and separate these this mesh into kind of like separate component objects. So the first thing is that it may be easier to work in orthographic view when you're doing this type of work. So you hit the numpad 5 and that'll switch your view so that we have a kind of a top-down flattened image. And secondly, we'll go ahead and start working on the component division here. So when we're working on like a component, we're thinking about this maybe thoughtfully. We'd have like one wall represented here on the side, and then we'd have this for this plate running across. Going back to this view, we would have like this set of vertices and maybe some sort of overlap in there, or maybe not. Just depends on how you want to design. I'll go ahead and actually create it where we have this front plate as kind of a separate component that's separate from this plate, that's separate from this plate. So what I'll go ahead and do is just cover like how do you choose the vertices that you want to choose, and then creating the component plate that you're wanting to work with. So in this case, we can work with the circle select, hitting C. If you want to toggle a selection off, you press and hold the middle mouse button. If you want to select, just press the C. And we'll go ahead and select like these two sets. Now I'm in, again, wireframe mode to do all this. Now we have all this work in between it that we need to select. And by the way, I'm in vertex select mode. So that's important. Make sure you're in vertex select down here, not in edge or face. So we've selected the vertices, and once we have it selected, it should look like something like this for the highlighted vertices. So then we'll hit the Shift D and duplicate that, and then once we have that duplicated, if we like what we're seeing in terms of like a representing plate, the component plate, we'll go into Mesh and select vertices and then click Separate and by selection. So that kind of covers like setting up a brand new plate. Oops. We'll see which plate we added there. So it's plane 3. And it may help kind of like for good design, naming practice, kind of keeping track of things. We'll put top and top lower so that we know it's a top lower plate. The next thing is that I do recommend having, like, especially if you're going to do design work, and go ahead and kind of move this out of the way, but somewhere where you can access it to, that you're actually assembling these plates as you're separating, duplicating the mesh into these component plate objects, that you're separating them and then reassembling it, and I'll show you how to do that in just a second, so that especially when you're doing design work, it makes it so much easier to like to see how that relates to like another component, and you can actually use the snap to function on that other component plate if you don't like if you're filling in vertices that are not included on the other plate. You can actually snap to those other vertices on another component object that's kind of aligned with it. So we'll go ahead and select this other plate, this front plate right here. So I'm going to go ahead and hit box select and just go, again, we're in vertex select mode. So we should have like, and this is what we're showing for that plate. I'll go ahead and duplicate it, hit Shift D, and then separate it. And let's see, separate by selection. So we have that separated, and we'll name that, let's see, yeah, plane 3. So I'll just rename it top or front lower, since we do have two front plates. So I'll go ahead and translate this, get it out of the way, but I want to go ahead and assemble this with the other model. So I'm going to kind of hit the numpad period, and we have a snap to on the vertices, which is a nice function because as I'm grabbing and I align it, it automatically aligns with the vertex that it's intercepting. Now we'll notice that it may not be like completely intercepted the way that we need it, like as it's, as the component is shown assembled. So we may actually have to do, well, actually it is, which is convenient. But if we needed to do further work and doing that, getting it translated properly, we could go into edit mode like on one of the components, and then we can kind of zoom in on a vertex and see how that lines up in relation to the other component object. And as necessary, just hit A to select all the vertices, and then you can use your G function and kind of drag it until you get like it translated to where it needs to go. But in any event, it should look like, once you separate each component, have it named, you'll go through the process of joining it with each of these components. So it's kind of like putting together, in this case, almost like a design jigsaw puzzle, where you're kind of completing it. And so when you have it kind of finished, you should have like a completed model. And I'll just open up this other file so that you can kind of see it. Let's see, Pedal Board 4. So when it's all kind of said and done, it's going to look something like, this, in terms of like each component being assembled and lined up with one another. So this is kind of like the process of breaking down your overall design into kind of these component objects. And again, the reason that we do this is that, especially if you're wanting to do like CNC milling work, you're going to have to do like two-dimensional projection mapping of this. And so like this front plate here, you'll have to change the perspective, not only to an orthographic view, but have it so that you have like given the normal faces that are projecting out from this plate, that your viewport is aligned either planar in a parallel or orthogonal context. You can't be slightly askew. Like for instance, if I'm in this view, I don't have an appropriate projection, that is adequate in representing on the CNC mill. This is not going to work, for like milling, a top-down milling with the router. So it has to be projected, in a plane context in the appropriate manner. So, again, we select like this. You've got to have your projection like this, something like this, where I'm using a combination of the 7, 4, 6, and 8, and 2 to toggle my view along with the period key to have it centered. And that kind of goes to my other tutorial that explains on projection mapping it, but that you can watch on that. But in any event, I've kind of covered the details of like the more intricate design work. I'm not going to cover like all of it because I did spend quite some time getting all this stuff set up. And we would be spending a lot of time in tutorial listening to me talking and kind of fumbling around and getting everything set up, since I don't exactly remember everything that I did going from component step to step, but I provided kind of some of the very, very important information, on kind of mesh work. The other thing is that when you're working like individually on the mesh, like if you're working with the vertices and you want to, and this goes with like, if you remember earlier when we were setting up in the previous tutorial, getting these holes matched to match the plane of the surface, like a surface face, we can actually use in a very useful way, use our transform orientation very purposefully the problem that we can see here, like if I choose the normal just for the vertex alone, I don't have any one of these axes represented that's moving along the line. So if I wanted to extrude project on this line, you want to have the transform orientation recorded for the line itself. So to record that, you can select two vertices that are matched up to the edge, and so once we match that, we can go down to, again, the transform orientation, hit the plus key, we'll pull up our tools shelf real quick, and with this dialog I type in A. As you may have remembered from the previous tutorial, we record the transform orientation, and with that recorded, now lo and behold, the transform orientation is recorded. So if I wanted to like extrude on a line and choose any point and extruding on that line, I can hit the E and then the Y and then the Y again, and that'll extrude on this, and it says right down in the left lower corner down here, well, I can't show you while I'm doing it, but you can extrude down downward like that. I'm going to pull off the, well, actually I'll kind of demonstrate it. So like if I didn't have this vertex here and I wanted to find it, and I already had it projected down here, so that I had kind of an orthogonal line 90 degrees running between the two parallel lines where it was projected. We had a line or point projection from this edge and this point to this edge and this point. We could do so by just hitting like the E, the Y, and then the Y again. And yeah, for some reason it's not wanting to drag down there, but that's how it would be done. Let me go back into my other mesh here real quick. Some reason I'm not able to do something kind of like basic like that, but it does work, and that's how you can like subdivide and do some very interesting stuff here. So like we were selecting this, and let's see. So yeah, I have these two, let's say I select these two vertices, select that, hit the normal, and we'll look at there we go. And so we can see that the Y on this line is being represented with that arrow that in between the two vertices. And so we hit the A, type in, hit the two check boxes, it's saved, and now we can select the vertex. I hit the E, Y, Y, and you can see now that when I'm extruding the vertex, it stays parallel, or it stays on the line. So I'm choosing any point on this line. So that's also a very important feature in Blender. Like when you're mesh reworking, I use this quite a bit. That type of procedure that allows me to kind of select things more easily when I'm finding what I need to find. So again, something to keep in mind again when you're reworking this. But in any event, I've kind of covered what I wanted to cover for this tutorial. I want to thank you for listening in, and you have a great day there.